Welcome to the Mr. Beacon podcast. I am giddy with excitement. It's not often that we get a new version of the Bluetooth spec out, and this isn't a point version. This is version 6 of the core spec that has come out with a ton of really cool features. The coolest, in my opinion, is something called channel sounding, which is really going to make some big waves in the real world because it's going to bring very accurate range finding to standard Bluetooth devices, not fancy, expensive devices, but regular devices will have centimeter level accuracy, which is going to open up tons of new use cases, tons of business opportunities, and some great user experiences. So we are privileged to have the cooperation of the folks at the Bluetooth SIG. They've been regular guests talking about new features. And I was delighted when Damon Barnes, who's their director of technical marketing, agreed to join me to have a conversation about this new feature. So without further ado, let's talk to Damon. So Damon, thanks so much for coming on the show.
Certainly.
So it's actually great timing. I just got the notification along with everyone else that Bluetooth version 6 is out.
Yes.
You head up technical marketing. I'm sure you've been fielding a ton of questions about that. And, one of the major features of Bluetooth 6, which was what we're going to focus on, which is channel sounding, range finding. And I think, you think, well, Bluetooth is done, it's there, but it isn't. It keeps on evolving and getting better. And from what I've heard, I'm very excited about this ability to get more precision in terms of distance measurement.
Yep.
And also, I'm really intrigued by some of the other features. I want to focus on range sounding because I think it's a subject in its own right. But can you give us just a quick overview of what is in version 6 of the Bluetooth specification?
Yeah, sure. Let me try to give you a little bit of an overview. So about 2.5 weeks ago, we released Bluetooth core version specification 6.0. A little bit of a mouthful to get out, but it included, what did it include? 6 features total, including channel sounding. I'll go through just a short overview of the other 5. Obviously, we're going to get into channel sounding, what it is, some of the detail around it, and all that good stuff. But the first one is called decision-based advertising filtering. Another mouthful. What this feature actually does, it improves scanning efficiency. It's beneficial when there are a large number of devices that use messaging broadcast, and this feature helps prevent throughput degradation when a large number of devices, for instance, like in a mesh network, are broadcasting messages. So that's DBAF is the acronym that you'll see used, like if you were to go to core after the first entry. And then the second feature is called monitoring advertisers. This feature basically enables HCI events to be used to inform an observer device, like when advertising is going on, help it better understand when a device moves out of range, and this helps provide an energy savings benefit. And then the third feature is ISOL enhancements. This feature really pertains to LE audio, and it helps reduce latency with respect to isochronous communication. And then number 4, this one's more of an enhancement. So this is a link layer extended feature set. That's it's a lower level enhancement, but it enables devices to communicate more information about link layer features that are supported by a device. And then lastly, not including channel sounding, of course, a feature called frame space update. This adds flexibility to connections or connected isochronous communication. So LE audio and even Auracast are features in a use case that can benefit from frame space update. So that's the other 5. And then, of course, we have channel sounding, which I won't go into now.
Right. But super interesting. We'll may drill into some of those on another occasion, but I'm certainly going to be looking into it. I work at Wiliot, that's my day job, and so we're super interested in how we scale to really, really large numbers of Bluetooth devices.
Yep. So there's a couple in there for you. Sorry, I didn't mean to cut you off, but yeah, there's a couple that in there for you to take a look at a little more closely.
Very good. Well, let's get on to channel sounding. For that, I'd really like to understand, what it is, what it can be used for, and a little bit of how it works. And we'll probably go in that order. So if people's eyes start to roll into the back of their heads on how it works, then they can drop off. Although I hope they don't, because we've got kind of an interesting conversation coming about how you got into the Bluetooth SIG and your music choices. But the Bluetooth specification works really well. But what I've found is people are constantly wanting to use it to try and identify where things are. And so the ability to get more accurate with less infrastructure is really appealing. Will channel sounding help with that? What does it do?
So channel sounding, I'm going to start kind of at a pretty high level, just so, especially if folks that are listening in or watching aren't that familiar. And then we can kind of, drill down into a little bit more of the detail. But I mean, at kind of like the highest level, the way that we messages or explain it from the marketing side, which you see in all of our public communications, we say that Bluetooth channel sounding is a secure, fine-ranging feature, and it's going to help enhance the convenience, safety, and even security of really any Bluetooth connected device. So if you have a Bluetooth device that's paired, a device or product that you can pair to another product, the Bluetooth channel sounding feature can be leveraged to essentially allow those devices to understand the distance between one another. And so that's how we kind of explain it at a high level. And then like if you talk about or want to talk about like use cases that can benefit from the channel sounding feature.
But just before we get onto the use cases, I just want to understand what it is. So you need a connection between the two devices. It's not something you can do just with advertising packets, which is the kind of
correct.
I'm here phase of the conversation. You broadcast some advertising packets, then you decide you're going to connect. And then once you're connected, then you can start to do this more accurate measurement of distance. And it's just distance. It's not like angle or arrival where it's distance and direction or...
That is correct. Those are a couple important clarifications to make. And I might kind of outline it a little something like follows. So channel sounding let me first hit on another point and just to reemphasize, channel sounding was designed to, just be a feature for Bluetooth connected devices. There's non-connected or connectionless, is I guess how we say it, on the Bluetooth SIG side or on the Bluetooth technology space, features for distance measurement and direction that are separate of channel sounding. And so what we kind of say is we have for Bluetooth technology, we actually have a portfolio of device positioning features, and the list of the portfolio kind of goes something like follows. So you have Bluetooth advertising broadcast that allows you to basically determine a device's presence. That can be that's connectionless. You don't need a connection for that, obviously. And then historically, the way that designers and product manufacturers would determine the distance between devices would be to use RSSI or receive signal strength. This can be connection oriented or connectionless. And then direction finding, of course, a feature from 2019, 2020 can be connection oriented or connectionless. And that gives you the direction. So the number, the degrees you are, where you need to go. And then, channel sounding is the most recent addition to this portfolio, connection oriented only, device distance only. And the nice thing about channel sounding, and maybe I'm going a little too far, but we can back off, is that you can get centimeter level distance measurement accuracy with this new feature.
And that's pretty amazing. So centimeter level distance accuracy, and we'll go into how and why, but that is really, really cool. And I want to just go back and recap what you said to make sure I've heard it properly and give people a chance to absorb it. So, you start off with presence. So, the advertising packets, which are basically the things that my printer uses to tell my computer that it's available for use, or that your earbuds use to tell the phone that it's the earbuds are nearby and available for connection. That can basically do presence, which is I'm here and you can receive me. And then you're here, but are you really close, or are you really far, or are you somewhere in between? And for that, you can basically look at how strong is the signal that I'm receiving. So like a lighthouse, if the light is bright, you're close. If the light is dim, you're far away. And if the light is somewhere in between that, then you're kind of medium. But it has problems because, radio waves signals go up and down based on all sorts of things, not just proximity. So that's why you kind of want other tools and techniques. But the good thing is it's relatively easy and straightforward, and you don't need a connection. And
correct. Yep.
Pretty much every device can do it. Every device can advertise, and so relatively straightforward. And then, of course, we've got the angle of arrival thing, which we've covered on other episodes, where get this. You have more sophisticated antennas, so you have to have specialist devices, and you can say, this is the degree of the angle that this is coming from. And so that allows us to infer distance when you have more than one receiver. But the cool thing about what you've described is I can find out distance, and I can just have one device talking to another device. I don't need three devices. And there's going to be a ton of applications for that, I would think. Let's go into why I would want to do that then. What were some of the use cases that drove the creation of this new capability?
Yes, certainly. I will say that as far as the use cases go, there was like one lead use case that was front and center, I should say. And that was digital key for automotive access control. And so that was the number one. And that's where we're seeing the most, I shouldn't say the most interest. I should say it's farthest along as far as like traction goes, like market adoption and whatnot.
So you want to know that hearing us, you've got a car park, you've got a ton of people, and you want to stop someone doing something nefarious or accidental, and you want to know how close is this Bluetooth key. I guess the key could be a smartphone.
Could be a phone, could be a fob. But and so it's available today with certain. It's the way the feature works is kind of available today already, but it enables passive entry, right? So as you get close, and then because the level of precision, the security, that it's the person who's actually in possession of the phone or the fob that's either about to or getting close to the car and close enough to unlock and allow them in, or they've gotten maybe far enough away after they shut the door to lock the door. And so that's really the front and center use case for automotive. I mean, obviously there's other, passive use cases around, call it just like automotive for passive, vehicle systems. But those are certainly possible also. But the entry and exit and locking the door is really front and center. And so that also applies to access control, at homes, doors, garage. So that's kind of cool as well as you think about like the automation that can be possible. And then because so many devices already have Bluetooth, it's not a big step to implement the feature as it might be if you were going for another wireless technology or something like that. And then you were talking just a little bit more about use cases, and then I'll pause for a second. I mean, there's really, we kind of touched on it just a little bit. I'll just emphasize one more time though that any Bluetooth connected device, that you pair, or a Bluetooth device that you pair to another device could potentially take advantage of channel sounding. And that's a really large number of devices. Millions, close to billions of devices. It will be billions of devices by 2028. And then, but as far as use cases like industrial, you could look at HMI type solutions, potentially taking advantage of channel sounding, controller devices for gaming, and even
HMI is,
oh, my bad. Let me explain. Human machine interface. So using basically a tablet, phone, or some type of like control interface in a manufacturing or industrial facility to control machines, or could even be, to program robots, things of that nature. And so, understanding the precise distance between those two devices is, that helps, improve safety is like one of the main, benefits that you could think of there.
what will a device maker need to do to use channel sounding? Like for angle of arrival, they had, you basically make a device that's the size of a small frisbee with quite a complex antenna, and you've got yourself a, I don't know, a $300, $400, $500 device.
Yeah.
What do I need to do if I want to include channel sounding into the smart speaker I'm making?
Yeah, that's a great question, and got a couple answers for you here. So you do not need the super complex. I shouldn't say super complex because there's a reason angle of arrival, requires the array. You do not need multi-antenna solutions to enable channel sounding. You can take advantage or run the channel sounding feature with a wireless SoC, system on chip, or IC, whatever type of integrated circuit that's designed in with a single antenna. That's number one. As far as the integrated circuit goes, that's going to be something that if like a device manufacturer already has a Bluetooth chip, they will need to check with their semiconductor manufacturer to see if the device will support channel sounding. Channel sounding does bring in some new physical layer type stuff. I will say I won't get into the detail because we're not to that part yet. So there is a possibility that like, a revved or new chip might be needed to support channel sounding and, just for the more advanced RF capabilities that are necessary. But that's those are really like the two main considerations as far as like adding the feature.
So it's part of Bluetooth 6. What's the story on backwards compatibility? Does this mean that I will have to buy an iPhone 17 in order to potentially use this with my phone? I guess it's up to Apple whether they even support it. There's kind of, you have a chip that has, the chip vendor has to support it. I don't know what else. It doesn't sound like you need a fancy antenna, but there's going to be firmware and operating system software changes that will be required, right?
That is definitely correct. I mean, you will need two devices that both support the channel sounding feature. As long as both devices support the channel sounding feature, the great thing about Bluetooth, it is obviously a wireless standard. I don't really need to say that, but I will say it. And so, the functionality, from, the controller level up to the host level is interoperable. So as long as both devices support Bluetooth channel sounding, it's, your IC supports it. I'm not going to say that it's like, a snap of the finger, but it's, a pretty straightforward process to add support to a product.
Yeah. And when will the chips be available that support this feature?
Yeah, so as far as, when we're talking about product support, there are, we get asked this question all the time. That we think chip support's coming this year. There are a number of different solutions like EVKs that are available already.
And what is an EVK?
Eval kit. So a semiconductor company, let me rattle off a couple names of companies that have announced support. Let me think about this. So NXP, Silicon Labs, and I believe TI all have channel sounding solutions. They're early implementations, but they are marketing and trying to sell those solutions to their customers today. And so the short, direct answer again is like enabling technology chips will be available this year.
Great. And
before the end of the year.
And have Nordic said anything? I know you don't speak for Nordic, but
Nordic, I am not sure of the exact status, but Nordic is a company that we're saying is supporting channel sounding. They partnered up with us on like the marketing and all that stuff. I'm not exactly sure of their eval kit, but they are definitely going to be, a leader as far having support. I can't say whether or not it's going to be this year or not, but I would expect it pretty soon.
Okay. So it sounds like all of the major Bluetooth chipsets will be supporting this feature. And then it'll be a matter of deciding, the people that are building the products will decide if they are going to use it. And I noticed you quoted Denso in part of the announcement. So I'm assuming, they make car parts, and I'm assuming they were part of the group there that was actually working on the standard. Is that stuff secret or not? Is the companies that worked on the standard, is that confidential? I'm not clear.
In what you can see, well, let me see what I can share. What you can see in core version 6.0, you can see a list of companies. I have I compiled a little list of companies just in preparation for this that are supporting channel sounding. It's fine to say that Denso's supporting it. So, and I left off a couple a minute ago. Samsung Electronics, I think you probably saw, they made pretty positive statements. They have a really nice demo that they showed off at our member summit last year. To prototype smartphones, had an app, and you could see the distance being displayed between the two phones that was
nice.
Synchronized. So that was really nice. Who else did I leave off here?
Apple, they're on the board.
Apple is on the board, but you know how Apple is. They haven't, they have a very good poker face. So we're not sure if they're going to support it or not. What I can tell you though, and this is public information, is that support is coming to Android. We have heard, and you can see in a sample code that it's slated to come to Android 15, and it's if you're familiar with those releases, it's QPR3, and that the really neat thing is that it the sample, if you were to go to the sample code android.com site and search channel sounding, you could find a framework for arranging arranging service for the clients and server devices. And then also they have a test app available. And so that's really early days for that to already kind of be in place and it to, kind of be available, in the public domain. So we're super excited about that. So, I don't know if it's going to be this year. Actually, I wouldn't even want to go there. But I mean, support's definitely coming to Android. And so that's, super exciting.
That is exciting. You can imagine they have their own brand of asset tags, battery-powered tags, that this would be just amazing, like the real Geiger counter feature, which would be very helpful.
Yep.
It will be very interesting to see what Apple do. As you say, poker face, hard to tell, but I was so disappointed when they put ultra wideband in their phones rather than angle of arrival. But my hope is that this will be something that kind of makes them think about using Bluetooth for finding the AirTags that they make. And that would be a cool application.
Yep.
That's good to know about what it's going to take to support. And, so there's an operating system element to this as well. Just because you got the chipset, that's not enough. Just because the device is integrated with the chipset, that's not enough. You need some APIs to access this, and I'm wondering if there's anything else I need to ask you about the operating system support, other than yes, Android is going to have it. I guess there's other software platforms, Linux and the like, that will probably end up.
I think they will. I don't have the detail, especially. I mean, I don't even have the detail period to say publicly what's going to happen, on the Linux side. But the thing that we're really excited about, and just to reemphasize that, we have a ranging profile in service that's use case agnostic, to the service is what basically enables the APIs. And so that's not adopted yet, but it's targeting adoption by the end of the year. The date that I saw most recently, it looks like it's late November, so it could be December. But so that'll be in place. And so with that, I mentioned it a moment ago. You go to the Android code search site, and you can see that there's a framework for using the service. So that's really great. And so that's there, that foundation is there, and and it's not tied to a specific use case. So that's actually quite nice.
Do you have a sense of how power efficient this feature is? Because my general sense is that with RSSI, you end up the received strength indicator approach for non-connected distance measurement. You're basically spraying packets out all the time and looking at the signal strength. Is this more, less, same, or don't know in terms of power efficiency?
We have members testing, but we don't have an answer that we can give right now that's like, is it better or worse? I mean, just to be, like really open. I mean, with channel sounding, you are adding an additional procedure to basically, run the signal exchange. So there, anytime you're running, RF signal, there's going to be power draw, right?
Yeah.
And whether it's more of a power draw or less than, RSSI with Bluetooth, we've actually asked for some testing on that. And so it's kind of underway, but we don't have the results yet.
Okay. Well, it'll be interesting to see. So let's is there anything else you can share about use cases that you've seen, the kinds of applications?
Let's see what other use cases. So I will say that I wouldn't be surprised to see, we talked for a few minutes about digital key, but on like the Find My devices or Find My networks, which you're seeing them called now, I wouldn't be surprised to see, announcements, not only, for the US and EMEA markets, but maybe in Greater China as well, about, solutions, potentially ecosystems that, support Find My, and maybe even, mentioning, leveraging the channel sounding feature. And, Find My is kind of like traditionally or oftentimes just thinking of like the little tracker tags or whatever. But, the interesting thing about channel sounding being connected oriented, I mean, almost any device really could kind of turn into a Find My type solution. And so I'm going to give you one that just kind of goes to my head with a challenge that I deal with the kids. So, a lot of like TV remotes these days, right? They're Bluetooth, at least some of the newer models, high-end TVs. It sure would be nice if you could, use your TV to kind of help you identify where that remote was when it's under a couch cushion, under the TV, something like that. So, you have to have the, remote paired to the TV. And so, that could be an interesting use case. And, it probably ends up being something that's controlled by a mobile app on a phone or something like that. So it's, but that's, certainly possible. So that's just kind of an interesting one that I think about. It relates to like kind of making the Find My networks use case, if I can just generically call it that, mean more than just like an item finding tag.
Well, you're saying that triggered another thought in my head, which is, yes, channel sounding is essentially just giving you the distance, not the angle. But presumably you could have two radios, say either side of that TV screen, that are both doing the channel sounding to your remote. And if it's centimeter level accuracy, then you can do some trilateration. Basically, you draw the radius, see where it intersects, and you've got yourself some really nice XY indoor positioning or outdoor positioning, even.
Yeah, absolutely. I mean, there's things, tricks, techniques. You know this very well. It's system level that can be done, and so using this channel sounding feature with other techniques, yes, you can kind of do some pretty cool things. So that's why we're super excited about it. And you saw great press coverage about, the feature over the last couple of weeks. So, yeah.
Great. Well, congratulations on that. So how does it work?
How does channel sounding work? Okay. So let's, because some folks may not be, let's kind of start at a high level, I guess. And I'll run through a couple of little pitches I have for you, and then you can query me back and forth. But so the most basic level, kind of just to reiterate, connected Bluetooth devices that have been paired. So a one-to-one topology. These two devices both have to support channel sounding, like I said. And what's going to really happen here is there's going to be a signal exchange between the two devices. The two devices, there's two distance measurement methods, but the one for precise distance measurement is called phase-based ranging. With phase-based ranging, what's happening is one device, which is called an initiator, this is the device that wants to measure the distance to another device. It basically sends a signal to the other device, which is called the reflector, which, as you might suspect, reflects the signal back. This process is repeated across multiple frequencies after that initial send. And then the distance between the devices is calculated based on the phase difference between the transmitted and received signals over those frequencies. And then, like I said, it's based on phase-based ranging. This is like a well-proven distance measurement technique that's been used for years and years, but we've now implemented the Bluetooth version or flavor of phase-based ranging. And so that's how you're able to get high accuracy distance measurements with Bluetooth channel sounding. And, one other just point on there is it's very accurate, but we're also seeing really good, really steady performance over good distances. We have testing results up to 50 meters today. And theoretically the solution or feature rather should work pretty well, 100 meters, even up to 150 meters. We haven't done testing at the 100 to 150 meter mark, or had members do testing yet, but we're hoping to get that done, maybe later in the year. But yeah, so that's the high accuracy distance measurement portion of the feature. So yeah.
Okay. So I'm going to my brain's chugging away trying to think about how this works. So, radio waves, a bit like waves on the ocean, they go up and they go down, and so there's an angle to that change.
Yep.
And you're able to somehow understand the phase that is at, and so given that the distance between the peak and the trough is fixed based on the frequency that you're broadcasting at, if you move forward by a centimeter, then you'll basically that wave, you'll interrupt it at a slightly different point in its cresting and falling. And I'm assuming that if you are doing that with waves that are at different frequencies, so they have different gaps between the peaks, and you kind of measure, what is the angle of the phase on a higher frequency versus a very slightly lower frequency, then that's kind of how you work it out. But how do you know that? I mean, there might be, I don't know how many waves there are going to be between some car keys and the car, but how do you know whether there's twice as many waves? How do you know that you're 1 meter away versus 2 meters away? I can see why you'd know, I'm 1 meter away and then I'm 99 centimeters away. But how do you know how many of those waves have gone up and down in between the
well, there's a time element also. So with the channel sounding, with phase-based ranging, there's the waves that you've done a very good job of just explaining, but then there's also time, how long it takes as well. So it's really those two. The device is really the initiators gathering phase and time information, and that's where we're able to run a calculation based on a formula to determine the distance between the two devices. And one point to note there on that is the channel sounding feature doesn't actually, or the devices don't use the channel sounding feature to calculate distance. That is done by a ranging algorithm that runs on the application. So just to kind of circle back to what I was just clarifying is that, we get the phase data, we have the time data that's passed by the controller basically up to the host, and the application is running a ranging algorithm, and it actually spits out a distance measurement calculation.
So you say it's an application, but is that an application running on the central processor unit on my phone, or is it running on the controller in the system on chip?
No. It would be on the host.
On the system on chip.
Yeah, it wouldn't be on the controller.
Okay.
Just to be clear.
All right. That's good. So amazing. You're looking at the difference in time it takes for a signal to get from the key to the car and then back again. The clocks to do that. It's incredible that they're accurate enough
Yes.
to make all this stuff work. I'm not an electrical engineer, so it all seems like magic to me, but I appreciate your explaining it. And I should add that your team have put some really excellent written materials. If someone wants to read this slowly and go into the 2 levels of detail below what we've covered, then Bluetooth.com, it's all there, and it's really comprehensive. So very good. Well, is there anything else I should have asked you about this that people have been asking you?
Let me see if there was something else I was wanting to tell you that maybe we didn't talk about. We talked about Android. I wanted to, here's another thing. And we talked about digital key for automotive. And this really goes back to market traction and adoption. I think it's just something to good to point out. I know you probably already seen these, but just for the audience listening in or watching, in Greater China, there's 2 connected car consortiums or standards bodies. One's called the Intelligent Connected Car Open Alliance, ICCOA, and then another one's called the Intelligent Connected Car Ecosystem Alliance, ICCE. Yeah, love some acronyms. Anyhow, both of those companies were publicly supportive of the channel sounding feature, and so they haven't said what they're going to do yet, but just the fact that they were willing to step in and go on record with us, we think that this feature in Greater China, massive market, has a lot of potential, and we may see some pretty quick adoption, in the Greater China market. So just throw that out there for folks that might be in APAC.
Yeah. Well, and I know, back to my day job back at Wiliot, we've been looking at the ambient IoT standards, and of course, Bluetooth is ahead there by a mile. It's the technology that we use in our battery-free Bluetooth tags, but there is work going on to try and catch up in the cellular space, and that's being driven by the Chinese as well. So it seems like in China they're really taking this digital to physical convergence thing seriously.
They really are.
Yeah, and they have the scale to put it to good use and to get the volume and to prove out the use cases and build out the network. So that's a good endorsement. So Damon, you work at the Bluetooth SIG. In my mind, this is an amazing organization. A relatively small group of people is influencing the standards that are part of literally over 1 billion devices that get sold every year. So I think all of us technical people are kind of closeted rock stars. We want to create something and have a big audience, and Bluetooth certainly has a big audience. How do you get this job playing in the Rolling Stones of the wireless technology business?
Well, I must say, I do feel like I was very fortunate to be able to join the SIG coming up on 3 years ago. The way it all transpired was pretty quick and seamless. Actually, a recruiter reached out to me over LinkedIn, someone who's still at the SIG, part of SIG staff, and asked me if I'd consider talking to them about a role. And we had a talk, and then I had maybe 3 or 4, maybe 5 more talks with various people, and just everything fell into place really quickly and seemed to make sense. So it was kind of like a no-brainer for me at the end of the day, and I couldn't be happier to work here. I mean, it is I would say fairly prestigious, and call it like the wireless industry. So I'm loving it coming up on 3 years.
So what was it about your career that you felt set you up for this role?
Oh gosh, it's been almost a decade coming, but I'll just give you a real quick overview. So I started working in the wireless technology space, primarily in Wi-Fi and cellular, at a startup that was acquired by AT&T back in 2005. And I worked in Wi-Fi service provider type space, up until 2017, and then moved to semiconductor side where I worked at Silicon Labs for almost 5 years. So that exposure to Wi-Fi for more than a decade, and then at Silicon Labs a broad portfolio. They have a really broad portfolio of IoT wireless connectivity. I think is what set me up well to be able to join the SIG, and then start getting fairly specialized, obviously, with Bluetooth technology over the last several years or few years.
And how big is the special interest group, roughly the size of the staff?
I would estimate it's probably 170-ish people total. Mm-hmm. That does include probably somewhere between 40 to 50 maybe contractors. But yeah, so pretty small, very nimble organization. And we operate very much like a startup.
Very good. Well, part of the tradition of this show is that I ask guests about 3 songs that have meaning to them. Do you enjoy music? Is that part of your life?
I do enjoy music. I got a little, probably bit of a curveball for you maybe as my responses. But before I get to that, that teaser, I will say that, growing up, my parents were both very much... music was a very big part of their life, and so kind of something was always playing throughout the years in the 80s as I was a little kid and all that good stuff. But so as far as like my songs go, the curveball for you is I kind of picked a few that kind of have meaning to me for different reasons. So I have 2 kids, 9, almost 10-year-old daughter, and a son who just turned 6, and so. I asked my daughter last night when I was kind of, looking through the material and getting ready for this. I was like, what's your favorite song right now? And so she is like textbook big Swiftie. And so her favorite song right now is Cardigan from the Folklore album, which is, a few years or so old. Personally, because I, get to listen to Taylor Swift quite a bit, on that same album, I kind of am drawn to the song called Exile. It's a collaboration with Bon Iver. I think that's a kind of a neat song where he starts off.
I got to ask you about Taylor Swift, though, before we move on.
Okay, yes.
Have you been under immense pressure to take your daughter to one of her concerts?
Yes. Constantly. And so I hope to one day make that happen, but it'll have to be the next round of, I think, concert series, I guess, whenever that happens. But nothing happening this year for those few stops she has the remainder of the year. That was just a little bit too crazy, short notice. But I think it's on, call it like the bucket list or something to get done for her when she's still relatively young.
Yeah, that's great. Yeah, I remember taking my niece to see the Spice Girls back and when they were a thing. And that was like, I knew that would be really memorable. I'm not a big Spice Girls fan. I mean, not that I've got anything against them, but not my cup of tea. And so when we got the opportunity to go to Taylor Swift, I'm like, really? But I went, and it was just one of the best concert experiences I've ever had. Just superlative stage production, kind of a marathon event, incredible buzz in the crowd, and just for great musicianship and the whole production, video, stage, costumes, performance, just incredible. Really, really impressive. So definitely worth having on your bucket list.
I will say, I mean, prior to her becoming like a big fan, it's probably happened, gradually, maybe not so gradually, but over the last couple of years, I never really personally listened to Taylor Swift either. I knew obviously who she was, but then, over the last year, 18 months, I've become much more familiar. It's part of the household almost, so.
That's great. Well, it helps you grow. Your children's interests become your
interests. Absolutely.
Okay, number 1, number 2.
All right, then number 2, my son, he's 6, just turned 6, but he has a very... he has a significant draw to music. Maybe it's like his grandfather. I don't, from his grandfather. I don't know. But his favorite band right now might throw you for a little bit of loop. Maybe not. I don't know. But it's Imagine Dragons. Initially, his favorite songs were Radioactive, and oh my gosh, I'm forgetting the other one, but Radioactive. But right now, the current favorite is Bleeding Out. And I double checked this with him yesterday, and he was like, yes, you need to say that one, Bleeding Out. I was like, what about Michael Jackson? Because he's a big Michael Jackson fan also, likes Thriller and all, all the hits and stuff. But Bleeding Out it is, Imagine Dragons for my 6-year-old.
All right. Well, I see where you're going here. You're getting all these extra tracks in surreptitiously. Very cunning. I appreciate that.
I wasn't really trying to do that, but it's just more context, I guess. I don't know. Maybe I should have been more brief with my answer. Anyhow.
Not at all. That's what it's all about. I do this mainly because I just enjoy having this conversation. And what was your third choice?
Okay, and the third one is more close to home for me. And so I mentioned at the outset that my parents were, big music fans. And when I was, how old was I? 22, the summer before my senior year in college, I did a study abroad that was primarily in Edinburgh, Scotland. Then we went to London, France, and some other stuff. But while we were in Edinburgh, the Rolling Stones were coming. And they just so happened to have I guess that's a little bit of a spoiler, but they just so happened to have, it wasn't sold out or whatever. So we went to this football stadium that was, in Edinburgh. I don't know exactly where, the main soccer stadium, and saw them put on a show. And it was an incredible show, kind of like what you're mentioning with Taylor Swift. And I think it was the first real earnest, large concert that I ever went to. So it had a big impact on me. And they played, obviously all the hits, put on a great show. It was 25 years ago. So, they were still a little younger than they are today. But so as far as the song goes, one of the songs that my parents used to always play, and I went and found one that really spoke to me that they would always play in the home, was Start Me Up. So that would be number 3, Rolling Stones, Start Me Up.
Very good. Well, I'm so glad you chose that one. It's a great song, and it tied in with my Rolling Stones reference earlier, so that kind of worked out. And
Yes.
It's the thing I love about this is it always triggers off memories for me. So my Rolling Stones story is round about the same time. I wonder if it was on the same tour. My wife and I were on holiday in Spain, in San Sebastian. We were staying at this quite nice hotel, and it's like we go to check in and there's just something buzzing. It's like the level of excitement and staffing was really intense. And I'm like, is something going on? And they're like, no, nothing's going on. And we're like, okay, we check in, we go to walk out. And as we're walking out, this huge bus pulls in with a small van in front of it. The van pulls up, and basically the Rolling Stones get out of the van, and we're like mouth open as Keith Richards walks past. And so basically we were staying in this hotel for the same duration as them, and their entourage was downstairs eating breakfast with us. And unfortunately, Mick Jagger did not join us for a croissant or any paella, but it was just being in proximity of that orbit was so cool. And it could have been on the same tour because it was around about 25 years ago.
Now that was an incredible experience. So that's awesome. Yeah.
Well, Damon, thanks very much for chatting with us. And I feel smarter as a result of getting that knowledge infusion from you. And congratulations on the standard. I think it's going to be really successful. And I can't wait to start using products that have Bluetooth core specification 6 and channel sounding as a part of it.
Well, thank you for having me very much, Steve. This was lots of fun. Happy to come back anytime.
Thanks for watching this episode of the Mr. Beacon Ambient IoT podcast here on YouTube. You can listen to this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video. And be sure to subscribe for more videos. For more information about Wiliot, Ambient IoT, and IoT Pixels, head over to wiliot.com.